Hello everyone, today we'll be solving AQA GCSE Chemistry Paper 1 Higher Tier May 2018. Guys, this is a part 3 video, alright, and we are going to be solving from question number 7 to question number 9 in this particular video. This question is about group 7 elements. Chlorine is more reactive than iodine. Name the products formed when chlorine solution reacts with potassium iodide solution. So guys, when chlorine will react with potassium iodide, the iodide will get displaced and turned into iodine, and the chlorine will displace the iodide and take its place and become chloride. So the products will be potassium chloride and iodine. Explain why chlorine is more reactive than iodine. Guys, if we look into the periodic table, we'll find chlorine in the higher up in the reactivity series compared to that of the iodide. So the thing is, chlorine's outer electron shell is closer to nucleus. So the chlorine nucleus has greater attraction to the outer shell, the outer electrons. And that's why the chlorine can gain electron more easily compared to that of the iodine. While on the contrary, the iodine, it has a lot of shells and the outer shell is farther away, so it cannot attract electron as much as that of the chlorine. So the iodide ends up giving its electron to chlorine and turns the chlorine into chloride. Chlorine reacts with hydrogen to form hydrogen chloride. Explain why hydrogen chloride is a gas at room temperature. Answer in terms of structure and bonding. So basically guys, hydrogen chloride is made up of small molecules, because when hydrogen and chlorine covalently bond together, they produce the HCl molecule. So hydrogen chlorides are made up of small molecules. So hydrogen chloride, they will have a very small amount of attraction between, which we call weak intermolecular forces between each molecules. And the small intermolecular force that they have, the weak intermolecular force that they have, requires a very little amount of energy to overcome. So which is why they're going to be gas at room temperature, because room temperature is a temperature high enough to provide it energy to turn into gas. Bromine reacts with methane in sunlight. Figure 9 shows the displayed formula for the reaction of bromine with methane. So we can see the methane has 4 hydrogen, the carbon has 4 hydrogen attached to it, and bromine reacts with that particular methane and displaces a hydrogen, all right, and forms a bromomethane. Table 3 shows the bond energies for the overall energy change in the reaction. All right, calculate the bond energy X for the CBr bond. So guys, in a question like this, we need to understand how many bonds are broken and how many bonds are formed. All right, in terms of the understanding that how many CH bonds are broken, we will see that there are 4 CH bonds broken. So we will have to take into account for that. So there is 4 CH bonds that are broken. I'm gonna give a detailed I'm gonna give a detailed version of how to actually do it. However, you can actually make it a little bit shorter by omitting few of the lines, which I'm gonna indicate in the end. So we're breaking 4 CH bond. We're also breaking 1 Br-Br bond. Okay, so 4 times 412 plus we are breaking 193 for the bromine bond, which total is equals to 1841 kilojoule per mole. Now we need to focus on bonds that are formed. So when talking about bonds formed, all right, let's see what are the bonds formed. We can see 3 CH and 1 CBr and 1 HBr bond is formed. So 3 CH, 1 CBr and 1 HBr is formed. So each CH is 412 and the CBr bond we don't know, so we will just leave it as X, and 1 HBr formed, HBr is 366. So this gives us a total of 1602 plus the X. Now guys, we know that bond broken and bond formed, we can calculate by using this, we can calculate the enthalpy change. So this particular reaction is overall exothermic. All right, so what we need to think of is here bonds broken, which is we're going to minus bonds formed, which is equals to enthalpy change or energy change. So the bonds broken 1841, bonds formed 1602 plus X, energy change is equals to minus 51. So when we make X subject, our value comes 290 kilojoule per mole. So our value comes 290 kilojoule per mole. Titanium is a transition metal. Titanium is extracted from titanium dioxide in a two-stage industrial process. We can see TiO2 plus 2 carbon reacting with 2Cl2, producing TiCl4 plus 2 carbon monoxide. And then in the stage 2, we displace the chlorine, we displace the titanium by using sodium. All right, and we get free titanium metal. Suggest one hazard associated with stage 1. You see, the hazard is we're using chlorine as in the form of gas. So if the chlorine escapes into the environment, it's going to be highly toxic. All right, so we just need to mention chlorine is toxic. Water must be kept away from the reaction in stage 2. Give one reason why it would be hazardous if water can come in contact with sodium. We know that sodium reacts vigorously with water. All right, sodium reacts very vigorously with water. So it's a very exothermic reaction and produces a corrosive solution of sodium hydroxide. So we just need to write one of the points. Guys, we do not need to mention the name of the sodium hydroxide, but we just need to mention that it produces a corrosive solution, or we can write a final answer, which is it produces hydrogen, which is highly flammable or explosive. Suggest why the reaction in stage 2 is carried out in an atmosphere of argon and not in air. So we know that argon is a noble gas, and noble gases, they do not react, so it gives an inert environment. All right, so we will say argon is unreactive. Titanium chloride is a liquid at room temperature. Explain why you would not expect the titanium chloride to be liquid at room temperature. Now, the main reason why you would not expect a titanium chloride to be a liquid at room temperature is because it's an ionic compound. All right. So metal chlorides are usually ionic, and they most of the metal chlorides, any metal chlorides that you talk about, they're salts. The salts are solid at room temperature. All right. So, and they require a very high temperature to actually melt. So, because they have strong electrostatic bonds of because they have strong electrostatic forces of attraction between the ions, all right, and they, because of that, all right, it would require a very high temperature to actually melt it. So that's why our expectation would be the titanium chloride is solid at room temperature. In stage 2, sodium displaces titanium from titanium chloride. Sodium atoms are oxidized to form oxidized to sodium ions in this reaction. Why is this an oxidation reaction? All right. So sodium atoms, when they lose electron, all right, they are oxidized. All right. Loss of electron is oxidation. That's why we will call it oxidation reaction. Complete the half equation for the oxidation reaction. So when talking about sodium, all right, sodium loses an electron and produces sodium ion and gives out that particular electron. In stage 2, 40 kg of titanium chloride was added to 20 kgs of sodium. So titanium chloride plus 4 sodium produces titanium plus 4 NaCl. Explain why titanium chloride is the limiting reactant. So basically we had excess amount of titanium chloride, all right, so that the sodium is in excess, all right, and so the sodium is in excess, and to make sure basically all of the titanium is reacted to produce titanium. However, we have to show our working how we came up to this particular conclusion. All right, titanium chloride is a limiting reagent. So what we have to do is, first of all, we have to convert, first of all, find out the MR of TiCl4. So once we find out the MR of TiCl4, all right, so titanium 48 plus 35.5 times 4 equals to 190. And we are finding moles of sodium. Then we'll have to do 20,000 divided by, the reason why we turned it into 20,000 from 20 kilogram is because 20 kilogram is equals to 20,000 grams. So 20,000 divided by 23, which gives us 870 moles. And when we find out moles of TiCl4, we will do 40,000 divided by 190, which gives us 211 mole. All right. So for reacting 211 mole, we would require 4 times that of, compared to that of that to sodium, so which would be 844 moles. However, we see that 870 mole is greater than, all right, 844 mole. Okay, so we will answer it in this way. 870 mole of sodium is more than the 844 moles of sodium that is needed. So that will be our written answer. For stage 2 reaction, the percentage yield was 92.3%. The theoretical maximum mass of titanium produced at in this batch was 13.5 kilogram. Calculate the actual mass of titanium produced. So since we theoretically were supposed to produce 13.5 kilogram and we had a 92.3% yield, so we'll just multiply it with 92.3% and this will give us our answer, which is 12.5 kilogram. Guys, when answering question like this, please have a look for how many significant figure answer that they are asking for. In this one, the exam standard significant figure is 3 significant figures, so we went for that. But if they would have mentioned us 2 decimal place, 1 decimal place or something like that, then we would have gone for that particular significant figures. This question is about acids and alkalis. Dilute hydrochloric acid is a strong acid. Explain why an acid can be described as both strong and dilute. The reason why we can call an acid strong, it's because it's the nature of the acid, means it gets completely ionized. But what dilute means is that even though the acid gets completely ionized, the quantity of acid in a large amount of water makes that particular solution dilute. So the acid is strong because it completely ionizes. However, since there is little quantity of acid within a large volume of water, makes it a dilute solution. So the answer can be written as follows. One point zero into 10 to the power minus 3 mole per dm cube solution of hydrochloric acid has a pH of 3.0. What is the pH of 1.0 into 10 to the power minus 5 mole per dm cube solution of hydrochloric acid? Guys, this is a very good question, guys. When we see that the factor here went from minus 3 to minus 5, minus 3 represent a pH of 3, so minus 5 will represent a pH of 5. Alright, however, there is formula and maths to do this. We do not need it because it's a very simple one. A student titrated 25 cm³ portions of dilute sulfuric acid with a 0.105 mole per dm sodium hydroxide solution. The titration results are as follows. Okay, the equation for the reaction is sodium hydroxide plus sulfuric acid, sodium sulfate plus water. Calculate the concentration of sulfuric acid in mole per dm³. Alright, so we can use only the student's concordant result. So how do we determine what is a concordant result? We determine a concordant result by looking at the results that are within 0.1 cm³ accuracy. This will be concordant result. So first of all, these two are cancelled because they are not within 0.1 cm³ accuracy. 22.10, 22.15 or 22.15, in all of these cases they are correct. So the concordant results can be titration 3 and 4, 4 and 5, or both 3, 4 and 5, because the 4 and 5 is the same value. All right, so we can just choose one of the values from there. All right, so we will conclude it like this. First of all, okay, so first of all we will choose the correct titrations. Okay, and then we're gonna make an average. So average titer. And then we're going to divide it by 3. So the average is 22.125. So we will just write up until 2 decimal place, 22.13 cm³. All right, now we're going to calculate the number of moles of NaOH. To calculate the number of moles of NaOH, guys, we will see that in every experiment we use 25 cm³. All right. In every experiment we used 0.105 mole per dm sodium hydroxide. So to calculate the number of moles of sodium hydroxide, we need to have volume multiplied by concentration. So our volume is 22.13. However, we need to divide it by 1000 to get the volume in dm cube, whereas the concentration is already in dm cube, which is 0.105. So that is mole per dm cube, or we can write mole slash dm cube. Guys, both are correct. So dm cube and dm cube gets cancelled in here, and what we are left with the moles. So the moles here comes out to be 0.002324. The reason why we need to mention such a big value, first of all, this is not our final answer, and secondly is that because if we were to take this particular answer to 3 significant figure, then we would have a wrong answer because we're leaving out such a big portion of it. So that's why we need to give it as many decimals as possible, which feels logical, like 3 4 at least, or maybe in this case the one you can see the first two zeros are ignored, so we at least try to give it up to 4 significant figures. So the next thing what you're going to do is moles of sulfuric acid. Now you see, in terms of finding moles of sulfuric acid, we'd have to understand a particular term called stoichiometry, means chemical ratio. If we have 2 sodium hydroxide, then it reacts with a ratio of 1 sulfuric acid. So if we have this many number of moles of sodium hydroxide, we would require half as that of sulfuric acid. So 0.002324 would be the answer. Great. So guys, continuing with that, all right, our final answer will become 0.001162 mole. Okay, now if we are trying to find out the concentration, all right, we know that concentration is equals to mole divided by volume. All right, so the volume must be in dm cube, by the way. So the thing is, our mole here is 0.001162, which is divided by the volume. Now in terms of the volume, if we see, the volume is 25 cm cube. So what we're going to do is we're going to put the 25, however we're going to divide it by 1000, because that gives us dm cube, and on top we have mole. When we do the math, we find out our answer to be 0.0465 mole per dm cube. Okay guys, now that's what we got as an answer. All right, we can put this particular answer in standard form as well. However, we need to find out what is our teacher's requirement and if there is any special requirement for here. So since there is no special requirement for this one, we can just go for 3 significant figure answer. Guys, after decimal, a 0 is not considered as a significant figure, as you can see. That's why we have 4 decimal places answer. So the answer will be 0.0465 mole per dm cube. Explain why the student should use a pipette to measure the dilute sulfuric acid and a burette to measure the sodium hydroxide. Guys, pipette measures a fixed volume. So for example, 25 cm cube, there is a fixed pipette that can measure 25 cm cube very accurately. So we can use that pipette. And for the burette, because the burette has a variable volume of the sodium hydroxide has a variable volume. All right, so we can use a burette because it is going to provide us answer to 0.1 cm cube accuracy. So our answer will be pipette measures a fixed volume accurately. Calculate the mass of sodium hydroxide in 30 cm cube of 0.105 mole per dm cube solution. Okay, so the thing is, since we have 30 cm cube, so we need to find out the number of moles, all right, within that particular 30 cm cube with the concentration of this one, 0.105 mole per dm cube. So first of all, we need to find out the number of moles. Now number of mole is equals to volume into concentration. So we can write in shortcut V into C. The volume is 30 cm cube. Because the answer is the point is given in cm cube, so to get it in dm cube, we'll divide it by 1000. Always remember, cm cube has to be divided by 1000 to get it into dm cube. So we'll divide it by 1000, and then we're going to multiply into concentration, which is 0.105. 105. And when we put these two things together, we will get 0.00315 moles. Now we know the mass of sodium hydroxide is 40. So if we were trying to find mass of NaOH, it will be 0.00315 times 40, which will give us the mass in grams, 0.126 grams. Guys, we are done with this particular question paper. Thank you for staying for this long. All right, and guys, those who are watching this particular video up until this end, please consider subscribing the channel and inform your friends about this particular channel, that question papers like these are being uploaded every day, and it's going to be really helpful for you if you watch them. All right, guys, I'm located in Dubai near DAP Metro. If you are somewhere around here and you require a home tuition in chemistry, biology, or physics, all right, in O levels or in GCSE levels, in IGCSE levels, in A levels, please you can knock me in the comments, and basically I'll provide you my email, and we can then communicate and we can get connected. All right, guys, thank you for watching the video. Best of luck for your exam. See you in the next video, guys. Bye bye.